Hello all. Today we will discuss about the most commonly asked question on switching, and that is VLANs. So the question that is commonly asked in an interview question, or most of the interviews that I have been to and I have heard other people talking about it, is can two PCs from different VLANs connected to different switches communicate without having a trunk connectivity between them? So to understand this question, let me draw the scenario. So we need two PCs. So let's draw two PCs, PC1 and PC2. And they are also from different VLANs. So let us consider that PC1 is from VLAN 10 and PC2 is from VLAN 20, and they are connected to different switches. So let us consider that switch 1 is connected to PC1 and switch 2 is connected to PC2 respectively. And the question is, can these two PCs talk to each other without having a trunk connectivity between these two switches? Meaning that the link between these two switches are not trunk link, they are access link. So obviously this particular port is also configured as switch port mode access and with the VLAN 10. Similarly, this switch is also configured as an access VLAN 20. So the question is, can these two PCs talk to each other? So if I give an IP address of 10.0.0.1 to PC1 and 10.0.0.2 to PC2, and if I do a ping 10.0.0.2, will PC1 receive a reply from PC2? This is the question. So I will give you some moment, take 5 minutes to think about the answer, pause the video and come back and resume the video to listen and understand what the actual solution may be, or what the understanding or explanation behind the question will be. So most of you would think that these two PCs obviously cannot talk to each other because these two PCs are on different VLAN, VLAN 10 and VLAN 20. But let me tell you that PC1 can indeed ping PC2, though they are on different VLAN, and though they are the switches are configured as access VLANs in access mode, these two switches can talk to each other, and we will see this in some time with a practical. But before we move on into the practical, let us understand why would this work. So to understand why would this work, let us understand the layer 2 header fields once again, or uh, the layer 2 header when there is an access VLAN configured and when there is a trunk VLAN configured. Let's understand that. So from our first video on the layer 2 and layer 3 header, we have seen these different fields in a layer 2 header, right? So this layer 2 header does not contain a VLAN field, right? So whenever the switches are configured as access VLANs and there is no trunk configuration on the switches, your Ethernet header or your Ethernet frame would simply look like this. That means they will only have preamble, SFD, destination MAC, source MAC, type field, data field, and frame check sequence field in it. So what I mean to say is that these two switches, switch 1 and switch 2, when these two ports or the link between them is configured as access VLANs, let's say here access VLAN 10 and access VLAN 20. So when switch 1 receives a frame from PC1, let me draw that PC1 here as well. So when this PC sends a ping to PC2, right? So PCs, of course, obviously do not understand VLAN. So we would have naturally configured these two ports on these two switches as access VLANs. So switch port mode, access VLAN 10 here, and switch port mode, access VLAN 20 here. Similarly, on these two ports also, we would have configured access VLANs. So when PC1 pings PC2, what would happen is that it is received by switch 1. Now, we need to understand that whenever there are access VLANs configured in a switch and there is no trunk configuration present on this switch, the access VLANs are considered as untagged Ethernet frames. Untagged Ethernet frame meaning that they will in the Ethernet header there will be no VLAN tagging present. There will be no VLAN tagging present. That is the meaning of untagged VLAN. So let me repeat, when there is an access configuration done and there is no trunk configuration done on this switch, all the access VLAN traffics are considered as untagged traffic. So on switch 1 and switch 2, the traffic from VLAN 10 and VLAN 20 are untagged VLANs. So now let us understand the flow here. So PC1, when it does a ping of 10.0.0.1 is the IP address of PC1 and the IP address of PC2 is 10.0.0.2. So when PC1 does a ping of 10.0.0.2, the frame or the Ethernet, the ICMP packet is sent to switch 1. So since these two switches are working on Ethernet frames and we are trying to understand access and trunk VLANs, let us not consider the layer 3 header here. Let's move on to the layer 2 header. So on switch 1, the switch reads the destination MAC, the source MAC. Since these two ports are configured as access VLANs, it will not have any VLAN tag inside the Ethernet header. So naturally, what switch 1 does is switch 1 what switch 1 does is switch 1 reads the destination MAC address, checks its MAC address table and forwards it out of the port. Let's consider this as port number A, right? So it forwards this particular Ethernet frame out of port number A. Now, when switch 2 receives this particular Ethernet frame, and as I said, access VLANs are untagged VLANs, switch 2 does not see any VLAN tags on the Ethernet frame. And switch 2 thinks that since this particular Ethernet frame does not have any VLAN tags, this particular frame belongs to VLAN 20 and it accepts that particular Ethernet frame and forwards it out of this port and that frame reaches PC2. Similarly, when PC2 responds to the ping, switch 2 sends the packet or sends the frame towards switch 1. Let's consider this as port number B. Switch 2 again will not have any VLAN tagging on the Ethernet frame because it is an access VLAN. So it will not tag any VLANs to the Ethernet frame and forward it to the other switch. Now switch 1 receives the frame from switch 2 and it does not see any VLAN tag. So naturally switch 1 also assumes that this particular frame belongs to VLAN 10 and it forwards that particular frame to PC1. Thus PC1 and PC2 can talk to each other though they are from different VLANs and there is no trunk connectivity between them. Let me show you practical and we will get into more details of VLAN tagging through it. So here, if you see, I have taken two switches and two PCs. So I have given the IP of 10.0.0.1 to this particular PC and 10.0.0.2 to the PC on the right hand side. So what we will do is we will configure the two interfaces on both the switches as access, and we will see if these two PCs can talk to each other though they are on a different VLAN. So let me open the CLI for this particular switch, enable configuration terminal, and the interface fast ethernet 0/1 switch port access VLAN 10. Similarly, for interface fast ethernet 0/2 switch port access VLAN 10. A very simple and basic configuration. Similarly, on switch 2, we will configure the two interfaces as VLAN 20. Enable configuration terminal, interface fast ethernet 0/2, which is the interface facing the PC, switch port access VLAN 20, and interface fast ethernet 0/1, which is facing the other switch port access VLAN 20. Now let us see that if these two PCs can talk to each other. So we'll wait for this link to come up and we will do a ping from PC 0 to PC 1. So this is PC 1 here. So the IP address that is configured on this PC is 10.0.0.2. We will try to ping the IP 10.0.0.1, which is the IP address of this PC here. So ping 10.0.0.1. If you see here, we are receiving a reply, though they are on two different VLANs. So let us understand how it worked through the simulation. So let's do a ping again. So this PC generated an ICMP packet with the source IP as 10.0.0.2, destination IP as 10.0.0.1, and the Ethernet header, that is the layer 2 frame. And let us see the details inside that particular frame. So if you see here, you have a preamble field, SFD field, destination MAC address, source MAC address, type field, data field, and frame check sequence. So if there is a VLAN tagging done on the Ethernet frame, we will also see two different fields, that is TPI and TCI. So in some time, I will also configure these two switches as trunk, and then we can see the difference of how VLAN tagging is done. So here, if you see, we do not have VLAN tagging. That means this particular Ethernet frame is untagged. So let us see how the switch receives it. So the packet is sent towards the switch. Switch has received it. Let us open. So the inbound packet, as we saw, meaning that the frame that has been received from the PC remains the same. We do not have any VLAN tag added to the Ethernet frame. Now the outbound field, let us check the outbound field. The outbound field also remains the same, meaning that there is no VLAN tagging done on it. So this particular Ethernet frame is untagged. Now, since this Ethernet frame is untagged, switch 1, which is on Access VLAN 10, it thinks that any untagged frame that I receive will be of VLAN 10, and hence this switch sends the packet to the other switch. Now let us open it. The inbound data from the other switch, switch number 2 here, is without any VLAN tagging, and the outbound, this particular packet which is being sent towards PC on the left hand side that we see on the screen here, is also sent without any tag. That is why any access VLANs that are sent across are sent without any tags. They are untagged Ethernet frames. Until and unless there is a trunk configuration done on the switch, these Ethernet frames would be sent as untagged traffic. The condition, again, I'm telling you, the condition is that there should be no trunk configuration. The moment there is a trunk configuration, these access VLANs will also be a tagged Ethernet traffic. Let me explain you that also. So here we can see if two switches are on different access VLANs, or two PCs are on different access VLANs, they can still talk to each other. The reason is that access VLANs are untagged VLANs provided that there is no trunk configured on this switch, and hence they can talk to each other. So now what I was trying to tell you, that if there is no trunk configured on the switch, the access VLANs are untagged Ethernet traffic. Now, if we configure trunk on the two switches, the link between these two switches, if we configure them as trunk, automatically the access VLANs are configured, or access VLAN traffics are sent as tagged VLAN traffic. So which traffics are then untagged traffics? That is where the concept of native VLAN comes. When there is trunk configured on the switches, the access VLANs are tagged traffic, native VLANs are untagged traffic. Again, if there is no trunk on the switch, that means access VLAN traffics are equal to untagged traffics. If there is trunk configured on the switch, that means access VLAN traffics are tagged traffic. So if there is trunk configured on the switch, native VLAN traffics are untagged traffics. So let us see that in action also here. So now here I have taken two PCs, or I have added two PCs and given them the IPs of 10.0.3 and an IP of 10.0.0.4. So what I am going to do now is I will configure these two PC interfaces as access VLANs and the link between the two switches as trunk. So let's go on to the interface configuration. So interface is fast Ethernet 0/3, um, switch port access VLAN. Let's say that it's 20, because this particular PC is on VLAN 10. So I'm configuring this particular PC on VLAN 20, right? Now going to the interface fast Ethernet 0/2, which is the access link facing the other switch. Interface fast Ethernet 0/2, switch port mode trunk, and I will allow all the VLANs. Trunk allowed VLAN all. Now let's go to the other switch. Interface fast Ethernet 0/3, switch port, access VLAN 10. Now interface fast Ethernet 0/1, which is facing the other switch. Let's configure that as trunk. Switch port mode trunk, switch port trunk, allowed VLAN all. So let's wait for all the interfaces to turn green. So now what we have done is we have configured all the interfaces facing the PCs as access VLANs and the interface between the two switches as trunk VLAN. So this particular PC that is on fast Ethernet 0/1 is on VLAN 10, and PC number 3 that is connected to fast Ethernet 0/3 is also on VLAN 10. So let us ping these two PCs, PC0 and PC3. The IP address of PC3 is 10.0.0.4. So let us ping 10.0.0.4, and we are receiving a reply. So now let us check the headers in the in the ICMP packet that has been generated. So let's do a ping again from that particular PC, PC0. So in this particular frame, if you see that the Ethernet header does not have any VLANs, any VLANs. So we just have a type field because PCs do not understand VLANs. They are not aware of any VLANs. They do not know which VLAN do they belong to. It is the work of switch to transfer the traffic from a particular VLAN to a different VLAN or a same VLAN. That is the work of a switch. So PCs of course do not understand VLAN, and they would send the traffic without a VLAN tag added. Now, when this packet is received on the switch, let's see what is the inbound and outbound data. If you see the inbound, that means the frame that is received from the PC remains the same. That is, we do not have any VLAN tags added because it is received from the PC. Now let's check what is the switch sending towards the other switch. So if you see here, we have something called as TPID and TCI, right? So TPID, I will explain it in some other video what is the meaning of TPID. But this TCI, TCI, if you see here in the Ethernet frame, whenever a VLAN is added, that means an 802.1q header is added, there are two different fields, right? So there are two different 16-bit fields. One is TPID and the other is TCI ID. Now in this TCI, we have the 12-bit VLAN ID, and hence the moment we created or we configured a trunk on the switch, the access VLANs were also converted into tagged traffic, right? So and hence we have a TCI value. This 0x000A, A is the value for 10, correct? And hence the value is given as 0x000A, and it is sent towards the other switch. So the other switch receives it. Let's pause the simulation and check. So the inbound details, if you see, remains the same. That is this particular, the same frame that was sent from switch 1 towards switch 2, right? So we have a TPID and TCI value, which corresponds to VLAN number 10. And since that particular PC does not understand, VLANs, that particular VLAN tag has been removed. But switch knows that particular interface, that is interface number fast Ethernet 0/3, is configured for access VLAN 10. It forwards the packet from that particular interface towards PC, and it removes the VLAN tag, and it is forwarded to the PC. Now, as I was saying that when trunks are configured on the switch, access VLANs are tagged VLANs or tagged traffic, but the native VLANs are untagged traffic. Let us see that also here. So what I have done is I have added two more PCs here to the switches, and I have not done any configuration on these two. The only configuration that I have done is on the PCs, and I have assigned them two IP addresses. Now, if you see on switch number 1 here, we have three VLANs. That is VLAN number 10, VLAN number 20. These two are access VLANs. And by default, whenever we configure a trunk on the switch or on a switch, the native VLAN by default is VLAN number 1. So if you see, fast Ethernet 0/4 has is connected to VLAN number 1, that is the native VLAN. Now, on this particular switch, if you see, we have the same VLANs, VLAN 10, VLAN 20 as the two access VLANs, and the default native VLAN as VLAN number 1. So now what I will show you is that when we ping two PCs which are a part of native VLANs, they are sent as untagged VLANs, untagged traffic. So let's ping from PC number 4 to PC number 5. Ping 10.0.0.6. That is the IP address of PC number 5. So if you see, I have not done any configuration on this switch. All I have done is added the two PCs to the switches, and they are pinging. Now let's check this in the simulation and see or understand what I was trying to tell. So on this particular PC, when the PC generated the Ethernet frame, the Ethernet frame obviously is untagged because the PCs do not understand VLANs. So when this particular frame reaches this switch, as we had seen earlier for VLAN 10, the switch added a VLAN tag when it was sending it across the other switch through the trunk link. But for a native VLAN, if we will see here that it will be sent as untagged VLAN traffic. So here, if you see, the inbound details of the Ethernet frame remains the same. That is, we do not have any TPI or TCI values. Similarly, the outbound, when we had seen the earlier example with VLAN 10, a TPI and TCI value was added. But here, if we see in the outbound side, we do not have any VLAN tagging. So this proves that whenever there is a trunk configured, the native VLAN or the native VLAN traffics are treated as untagged traffic, but the access VLAN traffics are treated as tagged traffic. So now let us play this again. The switch sends this particular frame to the other end, and we'll open the packet. Uh, so if you see here, the inbound, as I had mentioned, the inbound does not have any VLAN tags, and the outbound also will not have any VLAN tags. And this frame then reaches the PC. So in conclusion, what I was trying to say is that the question that usually is asked in the interview is that if two PCs are connected to different VLANs and they are connected to different switches, and if there is no connectivity between these two switches, can they talk? Yes, they can talk, but the condition is that the two switches should not have any trunk configured between them, right? So if the two switches, switch 1 and switch 2, let me open the simulation itself. If these two switches here, if the link between them, that is this particular link, is not configured as trunk, if this link is not configured as trunk, the two switches can talk to each other. This is, for example, in our example, we had made this particular interface as Access VLAN 10 and this as Access VLAN 20. So if all these PCs are part of VLAN 10 and all these PCs are part of VLAN 20, they will be able to talk to each other. So when there is no trunk configured, the access VLAN traffic is treated as untagged traffic. When there is a trunk configured on the switches, the access VLAN traffic, as we had seen in this simulation, are treated as tagged traffic. And the native VLAN traffic, if there is a trunk configured, the native VLAN, which is by default on Cisco switches, is 1. The native VLAN traffic are treated as untagged traffic. So the concept of tagging and untagging is the reason behind why two different PCs on two different VLANs can talk to each other when there is no trunk involved. If you have any doubts, please do comment on the please do ask me questions on the comment section, and I will try my best to answer those. Thank you and have a great day.